Hello and welcome to the March 2022 event for the Atlanta Kubernetes Meetup. We are happy to have you here today with us. As always, we'd like to start off with a call for hiring in the community. If you or anyone at your organization is hiring for roles relevant in the Kubernetes or cloud native space, go ahead and post information about that in the chat. Include basic info about the role, how people can find out more and who they can contact about it. I'll also go ahead and record that information and put it in the show notes so people watching the recording later on can find that information as well. And then after we finish up with the news segment, I'll go ahead and read those out. And while you go ahead and get those posted, I'll hand it over to my buddy Joe to read the news to us.
All right. Let me get my screen sharing going on. And if somebody could give me a thumbs up that the font's okay, readable, we're good. All right, cool. So welcome back. It's been a little bit since I've been here and since we've had a news section. So I'm glad to be back into it. We are currently in the Kubernetes 1.24 release cycle. We had the 4th alpha release dropped this month, so we're getting really close. I think all of the enhancement freezes are in place now, and it's the last little bit of work to get all the tests passing and the flakes smoothed down of CI and whatnot. So should be able to see 1.24 drop here pretty soon. Reminder that we are in the cycle to where we have 3 releases per year now with Kubernetes. And we did have fixed releases for the current supported version, community supported versions of Kubernetes, which is 1.23.5, 1.22.8, 1.21.11. These include a number of backported bug fixes from a lot of the work that's been going on in the 1.24 release cycle. So if you've got clusters running around in those versions, take a look and upgrade as you see fit. Again, the NAs here for promotions, deprecations, and CVEs does not mean that there were none, just none that want to call out or anything right now. So we'll jump down into PRs of note. There were a couple things that were pretty interesting. So one of the things I felt like I'd been out for a little bit, but the auto generations of secrets for service accounts. This is kind of an interesting one. And again, if you're new to this, I'm not going to go into all of the explicit detail on here. We provide the links in the show notes so you can go in and take a look at your own, but I want to give you a little bit of an idea so you can kind of understand what's going on here. But historically in Kubernetes, when a service, every namespace gets a default service account, and every service account that you create gets a token, a secret that contains a token for that service account to communicate with the Kubernetes API. This is something that this behavior is sort of changing to where those secrets will not be generated by default. So this is kind of cool, a little move towards, a little bit more of a tighter security posture. But this is something that you can toggle on and off sort of, at least in the immediate versions of Kubernetes. And if you have any tooling where you're generating like a kube config based on that service account token for authentication to remote Kubernetes clusters and things like that, this could potentially impact those types of workflows. So encourage you to jump in and read a little bit more in detail. There is a link to the KEP, the Kubernetes enhancement proposal out here that kind of goes through and talks way more in depth about all the information on the who, what, when, where, and why that this is coming about.
That is super interesting. I was totally unaware of this.
Yeah. I happened to just be reading through the PR merges, and I was like, that seems very important, and I was not aware.
Are new tokens going to not use secrets at all?
So yes, they'll be in memory only by default. And I think there's an annotation that you can add to either the namespace or the service account. I can't remember right now, that kind of can toggle that on and off. Wow. There's a lot of work. This has been done in like sort of multiple stages over the past release or two. And this is kind of the first big impact, like user-facing impact of that coming up in Kubernetes 1.24. So
this makes me really excited because I've spent years of my life now on this problem of like using user impersonation instead of service account tokens for GitOps operators and stuff, and I haven't been able to get any traction on implementation or and like finish the implementations myself. So now this is going to be a forcing function for that sort of thing, because those legacy tokens and secrets are often used as a privilege escalation route legitimately for a lot of different sorts of controllers in Kubernetes clusters. So
yeah,
interesting.
Absolutely.
Hopefully they'll accept my talk abstracts now to KubeCon.
One of the other really interesting things that I came across is a sort of switch in the overall management of how beta APIs are handled within the Kubernetes project and the Kubernetes API server itself. So we all sort of joke, or a lot of us have been joking for years, what does beta mean in a cloud native landscape? Because usually that's the alpha version of the API and, so on and so forth. But in a push to further sort of bring a higher degree of resiliency and consistency to Kubernetes releases and things of that nature. Previously, alpha APIs were turned off by default, but now moving forward, net new beta APIs will be off by default within the Kubernetes API server. So any existing beta APIs that were owned by default in previous versions of Kubernetes will maintain being owned in 1.24. And at least for the next probably couple releases. But going forward, any net new beta level APIs will be disabled by default. So you'll have to actually go in and, if you're bootstrapping with kubeadm, adjust your API server flags or however you build your clusters, make sure those are adjusted if you do depend on any beta level APIs at this point. So something to be aware of, as high potential for impact of folks, since this is a pretty big shift in the way things have been done. And again, here I've got the issue for implementation, the KEP, and some other stuff here. And it looks like I've got some indentation wrong here in this document, but we'll talk about this anyways. So over the past release and a half, I think there's been a lot of work to sort of increase the expressions available for CRD validation within the Kubernetes CRD landscape. So if you're not familiar, Kubernetes has a great extension model with custom resource definitions that allow you to sort of bring your own APIs and have them treated as native primitive APIs almost. And as you define those APIs as CRDs, custom resource definitions, you're able to express certain things for validation of the individual fields within those custom resources. In the past, there was a kind of a shorthand validation logic that was available, but not a lot of expression. And there's been this work to move to CEL, and I forget, that's like Q extension language or something like that. I forget what it is off the top of my head, but essentially it's a much more expressive kind of almost full language for validation of these fields. And with that, there's an interesting thing that you gain with it, where you can essentially, the API server can pre-calculate the cost of that expression for the fields. And because of that, there's some new ranges, if you will, to be able to set like maximum expression cost or runtime cost for an expression. And the API server can kind of auto remove any expressions that go over that sort of threshold for that cost to protect the API server and the other activities within the cluster. So pretty cool to see a lot of work going on here, and to see that extension point of CRDs for Kubernetes just become smarter. All right, moving on into the community news sections. There is a huge discussion around Kubernetes reliability and sort of what does it mean to have reliable and consistent Kubernetes releases and things of that nature. So if that's something that you've got a lot of ideas around or really strong opinions, there's the original KEP that sort of defines the spirit behind the initiative. And then there's a discussion thread within the developer group to kind of jump in, share your thoughts and ideas, and help make sure the project is moving in the right direction for the community. So if that's important to you, jump in and help out there, please. Another thing to bring to your attention is the Docker shim removal. This is one of those things that's kind of, the sky is falling, a year or two ago with the initial sort of removal of Docker as, a kind of standard container runtime under the covers for Kubernetes. And that's been there for a while, but we've had this Docker shim layer in there that sort of handles the translations of the layers between the kubelet and the container runtime and the existing sort of legacy interfaces with the Docker container runtime versus the container runtime interface here. And so this is actually being fully removed, which hopefully most of us have been paying attention. We're up to date on Kubernetes releases already, and this won't be a huge problem. But if you do have any tooling that kind of operates at the node level and depends on like mounting a Docker socket or anything like that, it's a good time to go in, take a look, and reassess things and see what you might be able to update. There's tons at this point of alternative container runtimes out there that have been out in the real world, battle tested at this point. So take a look there and make sure you don't slip up when that gets removed fully. And there's a lot of kind of next steps. The Kubernetes, the official blog from Kubernetes has several good articles out there, kind of talk about the why, what the deprecation timeline is, next steps, all that stuff, as well as some migration notes and then general frequently asked questions. Like if you're still not really sure what the heck this is and what's going on with it, you can definitely dig in there and get more information. There was a recent spotlight on SIG multi-cluster, which was really interesting to me. Over the years, we've seen things like Kube Federation version 1 and version 2 come in and sort of fizzle out. And there's been a really great group of people in the background working on these problems. And I think these were like just really, really hard problems to solve. And with some of the enhancements to the kind of core Kubernetes service APIs, I think a lot of the work is getting in place now that makes this a little less complex. Again, thanks to the awesome work of the folks in the community here. But it's really cool. Sorry, I'm not looking at the right thing here. Let me get back and make sure I open the right thing. Oh, I got a bad link there.
The link's there on the left if you look in the menu for the blog.
Yeah, there we go. There we go. Thank you. So this was sort of a blog interview style with I can't remember if it's one or more of the folks from SIG multi-cluster. And it goes through and talks about the kind of the multi-cluster services, which is one of the first abstractions of how do you define a service across multiple Kubernetes clusters, things of that nature. It's really interesting. I think this is going to be probably one of the big areas of progress over the next couple years within the Kubernetes landscape, when people get past how do I install and manage things in one Kubernetes cluster to how do I install and manage things across multiple Kubernetes clusters. So really interesting read, dig in and check that out if that's interesting to you. Here's a fun one that's not specific to Kubernetes, but thought it was kind of interesting. So this is a Go library, Golang library called Script that essentially takes a lot of the annoying stuff to do really, really simple tasks that are like more procedural in nature with Golang, and makes them as easy as writing shell scripts. So a lot of the things you do, like examining files, writing the files, piping between different programs, things of that nature. It's got a lot of built-in methods here that simulate those same things. So the amount of boilerplate that you have to do with like full Golang from scratch or whatever gets pretty simple, even into like calling out to other commands and things like that. So if you want to have like really, really portable sort of administrative scripts where you could cross compile different like whatever, like this is a really cool way to to handle that. And I know I've personally found myself in these scenarios where I sit down and I'm like, well, I want to do this thing. And I know it's like 5 commands that I would run on the command line. Those fit into a bash script, like really easy. But we're really trying not to litter, little bash files everywhere like we've become accustomed to over the years. So really cool project here to kind of help with some of that. Another big one, security, ever being vigilant these days with the frequency and kind of heightened risk of a lot of the recent CVEs that have been out in the wild. The group behind the Kubernetes hardening guide has provided updates based on the recent security landscape, the recent updates to the Kubernetes project itself and whatnot. So if security and Kubernetes are 2 things that are in your realm of purview, this might be good to jump in and review. The hardening guide is very in-depth, so definitely not going to cover more than that, but if it's important to you, go check it out. So this was interesting to me, and this has been around for a while. This isn't anything that's like brand new, but it just kind of clicked in my brain when I saw a blurb about it recently, where there's lots of tools that have been out there to kind of help you do static code analysis on your more traditional, application development environments. If you're building a Golang application or you're building a Node application, there's tons and tons of static code analysis engines out there that you can plug into your CI system and do fun stuff with. But this checkoff goes a little bit further, and it actually can look at your Kubernetes resources and your infrastructure as code stuff and perform static code analysis of those types of resources as well. So that's pretty interesting. It's got an ever-growing kind of library of things that it supports, from just raw Kubernetes to Helm, Terraform, CloudFormations, customized Docker files, just lots and lots of stuff there. So if you're into that area where you're just getting started with, GitOps style management of your Kubernetes ecosystem, or you're already there and you just want to bolt on one extra thing to help, kind of keep consistency and whatnot in your environment up, this is a really good thing to just kind of plug in. And KTOP. So sometimes you just want to get a really quick, all-encompassing view of a cluster in a kind of snapshot way, especially if you're in an SRE type role. There's tons of tools, tons of dashboards, tons of things out there. If you've been around the Unix, Linux space for a long time, hopefully you're familiar with the top command. And there's been some like kubectl top things in the past that interfaced with like the metric server, and that's been, supported, not supported, changed from REST to gRPC, configurations all mocked up, all that stuff. But this is very, very close to just old school top, but for Kubernetes. Launch it and it'll give you a really great snapshot into your cluster. You can add in, a -n for a specific namespace and scope the information to that namespace. So lots of cool little powerful things there. It's got some very rudimentary point in time metrics type stuff. But yeah, if you're familiar with top, you're familiar with Kubernetes, you hopefully get the idea of what this looks like, but pretty cool.
Is there an operator? I need a KTOP operator.
I believe you would be the operator. And then I will talk a little bit more about Sonobui in my portion of the presentation coming up. But a quick overview of Sonobui has been a tool in the Kubernetes ecosystem for a while now that helps sort of run Kubernetes conformance tests against a cluster to say, yep, this is a Kubernetes cluster. Yep, it operates the way we want it to. But that group did a really cool job of making that Sonobui extensible with like a plugin interface. And one of the examples out there, they now have what they call a skeleton template or so, where you can take the existing Kubernetes end-to-end frameworks and use them to build in your own like functional tests for your application or your ecosystem or your environment, and have those captured, displayed, and reported through the Sonobui tool. So this is pretty cool. If you've got, you know, 5 or 10 or 100 different tests for your application deployment that you want to check that this pod is up and running in this namespace and this other pod's up and running in this other namespace and the services work and you can ping from here to there, make a REST call, all that stuff can kind of be captured. And rather than having to start from scratch to stand up your client Go, you know, stuff and make sure you've got this version and that version right, and how you authenticate and do all that stuff, it's all just there. All the stuff around how you define your jobs and different things like that, the framework's already there. So you can kind of clone this repo, go in and add your own tests, tie into the existing frameworks, the existing client that they have stood up, and then report it all back through Sonobui. So kind of cool with that. And that takes us to the end of our community news section and the end of this month in Kubernetes. So I will hand it back over to you, Alex.
Thanks, buddy. Solid news. So we actually have had no hiring announcements posted. You still have time to do those, but we probably won't be reading them live. So if you do realize you missed the window, go ahead and post them and we'll still get them into the show notes. Moving on from there, as always, want to thank our sponsors. SalesLoft provides us with the.
I'll just put that in there. You know, my old employer, Weaveworks, they are looking for some people to work on the Flux project and stuff. So pretty cool.
Awesome. Yeah. So I imagine if you're in the Kubernetes space, you probably know Weaveworks. They make a ton of tools that everybody uses every day. Definitely check them out. So as I was saying, we always want to thank our sponsors. Provides us with the licensing we need to do this fancy webinar and all that fun stuff. And in better times when we're in person, provides us with a location and food and drinks and all of those wonderful things. Speaking of in person, we'd love to hear people's sentiment on getting back in person, how you'd feel about that, if you'd be comfortable meeting in person again, or if you want to hang out at home and watch them remotely for a while longer. Definitely let us know. Hit us up on Twitter, meetup.com, or just find us on Tech404 or anything like that. Let us know how you feel. We'd love to kind of get a sense of people's sentiment around getting back in person. All right, so moving on from there, we are going to do our first talk. As always, you can use the Q&A feature. If you look on your bar in Zoom, look down at the bottom for Q&A, you can post questions in there and our speakers will see them pop up and they'll answer them in real time. Feel free to just go ahead and post them as they cross your mind, and they'll be addressed as they see them come in. And then make sure to stick around until the end of our event for our social time. That's where we kind of try to recreate the in-person chatting time and actually let everybody get on the mic and on camera and talk a little bit. So no further delay, I'll go ahead and kick off our first talk. This is a guest you are going to be very familiar with. You just heard him talk for a while, Mr. Joe Searcy, a staff engineer at T-Mobile, is going to be giving us a primer on Kubernetes load testing and benchmarking. You're muted,
Thanks,
buddy.
Alex. See if I can get my screen shared again. Okay. Everything okay, readable and whatnot. I'm not going to full screen it because I'm going to be jumping back and forth between the few slides that I have and CLI and some other like tooling and whatnot. But yeah, so my talk's just going to be a very simple intro into Kubernetes load testing and benchmarking. And as usual, this is kind of one of those things that when I've been out and about talking with other people, you know, you get one cluster and 5 clusters, 10 clusters, 100 clusters. You got lots of clusters out there and you've been doing upgrade after upgrade after upgrade, and you upgrade your OS or your firmware or your Kubernetes version, or you tweak this little knob tuning here or there on your CNI or your ingress controller or your service mesh or whatever. And then something doesn't work the way that it used to. It's not as snappy, it's not as fast, you can't fit as many pods in there, you can't do this, that, or the other that you expect to be able to do. Or maybe everything's perfect and you don't ever notice, and then all of a sudden one day things come to a screeching halt and you have no idea why, because you've never paid attention to any of this stuff. You know, been there, done that. I'll raise my hand to some degree. You know, especially with like persistent storage workloads coming to Kubernetes and databases and message queue systems and things like that. Data transferring over the network and the network going between the nodes and kube proxy and all this other stuff in there. There's lots of things in this picture. And we're going to talk about how you can kind of tell how things are going and how things should be. A lot of people usually use the terms load testing and benchmarking interchangeably. And in a lot of cases, that's probably okay. But in some cases, there's an important distinction between them. So let's start there. And again, not to insult anybody's intelligence, but just so we're all talking the same language here. So load testing versus benchmarking. Is there a difference? Yeah, sort of. And essentially here, when we talk about load testing, we're just talking about simulating load against something. And a lot of times that's, let's see how much it can take. Let's see where it falls over. Let's see when it breaks. Whereas benchmarking is sort of based on the concept of load testing, that we're, you know, putting load against the system, but it's more of a, let's put a known quantity of load against it and then measure how it performs. And then we're going to keep track of that. And then we're going to do it again. And then we're going to compare those things. So that's kind of a very simplistic level. One of those things is, you know, let the floodgates open and see what happens. And the other one is let's open up, let's dial it to 10, not 11, you know, and then compare every time, dial it to 10 and see what happens and compare the results. So, you know, why would we do one versus the other? Kind of already talked about that. You know, sometimes you do really want to see the upper bounds of what a system can handle. You know, take an ingress controller, for instance. You know, say you work for a large retail company and you have a website that sells widgets, and every year at a specific time, you have a big widget sale. And you want to be able to, you know, sell as many widgets as possible. And you know that last year at the same widget sale, you were able to sell 10,000 widgets. And that was at a rate of, say, 200 widgets a second or something like that. Well, you want to know that you can at least do that. You probably have all these fancy projections and equations to calculate, you know, last year plus 25%. Blah, 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 based on market trends and conditions and, you know, the economy, all this stuff, right? So you want to be able to test these things, and you want to know where your upper limit is from, you know, what kind of target that you expect, but you also want to make sure that you have some headroom to go above that if something happens and it goes a little bit different than you plan. What you don't want is your widget website to go down so that you can't sell any widgets whatsoever. So that's kind of where the load test comes into play in combination with benchmarking. So the benchmark would be, last year we sold 10,000 widgets. We want to make sure that we can sell 10,000 widgets now, but we also have a projection that we can sell like maybe 50%, up to 50% more, and we'll be okay. So that's going to go into how you set your thresholds for alerting and monitoring and things of that nature. But you also want to test that in advance. You don't want to wait till the day of your widget sale to find out that, well, we couldn't actually do that. We thought we could last year, but those 4 or 5 upgrades, you know, we're being good. We're upgrading our Kubernetes version, you know, every quarter or so. And then something changed and you can't sell those 10,000 widgets anymore. So you want to benchmark to make sure that you're maintaining the same level of service, either capacity, throughput, latency, whatever it could be. And then sometimes you want to just do kind of onboard load testing to see what your actual upper limit is, to know when you really need to start sounding alarms, you know, as you get close to certain thresholds. So I'm going to break down some of these tools. And this is, again, this is just going to be really, you know, open, interactive, and raw. There's no real concept here other than I'm going to break things apart into different categories of testing that you can do for the different kind of components or interaction points with a Kubernetes cluster. So the first part is going to be networking related and north-southbound networking. And this is typically going to be your ingress controllers, your ingress gateways, node port services, like whatever you use to get traffic into a Kubernetes cluster that exposes the services running inside your cluster to the outside world, where your, either other machines or services or external partners, clients, API subscribers can interact with those services. And sadly, the demo gods have not been in my favor today for me to show you this interactively, but this is kind of a screenshot here where you can kind of see in a simple, just like sandbox environment, what this looks like. And so I'm going to jump over here and just show you. Locus is open source load testing tool. And it's pretty cool. If you've ever done any type of load testing stuff, you've probably come across this tool or a tool like it. There's Vegeta and Apache has a tool as well, that essentially you have one or more client services that are going to try to simulate users or subscribers of some type of web service or API. So whether that's they authenticate to a website and they click on, button X, or they navigate to, page Y, you can kind of do a lot of different things there. And then I'll show you here a very, very, very rudimentary file. So this is Python. This is kind of what Locus uses by default. And essentially, they have libraries that you can import in, and then you're going to kind of build out your user behavior, and then talk about your target service that you want to send traffic to, and then any type of rules or configurations that you want for that traffic being sent to those to that service. So again, this is basically as simple as you can get, where I have one endpoint and I want to target one path on that. This is the simple HTTP service. It has a /headers endpoint. So you send a request, you get a payload back that are the request headers. So very, very simple. We're a bad actor here. We've got TLS verification turned off because it's a test. And then we're just saying that we want, this is milliseconds here, min wait time is 100 milliseconds, max wait time is 200 milliseconds. Now, you can go way more advanced than this. If you get into the documentation for Locus, you can do all sorts of stuff. If you want to simulate like a full interaction on, say, like an e-commerce site where a user logs into their accounts, they navigate to a products page, they scroll through a list of products, they click on a product, they click add to cart. You can do all of that stuff. Obviously, you got to spend the time to sort of build out that Locus file. And then if you want to set other parameters like connection timeouts and different things like that to simulate all different sorts of failures, you can do that to your heart's content. The main thing here is we sort of look at this in two different ways in my shop, where we have this basic, simple as can be Locus file where we just want to test the upper bounds. Given a perfect world where friction doesn't exist, the absolute smallest payload size possible, and the maximum number of virtual users, the lowest amount of wait time between each request. We really just want to see what's the maximum request rate we can get per second, with, as we have a target of 0% errors. 0% errors, weird thing that doesn't mean zero errors, it just means 0% errors in your test space. We set, the length of time that we want to run a test for. And that's the big thing. You want to take the scientific method a little bit and approach these things with it here, where you're making sure that you're comparing things each time with known parameters. But so a lot of times with testing north-southbound, it's going to be the number of concurrent connections, sustainable connection rate, with the lowest possible error rate and the lowest possible latency. So you're going to want to set a parameter like, we want to be able to sustain 50,000 requests per second with a 0% error rate. and we want to maintain 1 second, max latency latency of 1 second, you know, so that sort of stuff. Whatever's important to you, that's going to be different for everybody. So this is just kind of to show you, you know, what's out there, one of the tools there. But essentially, you can deploy the manager for Locus, and that's kind of the coordinator for the work. And then you have the workers for Locus, which are the bots or minions, if you will, that receive the work and simulate the virtual users as they access your service or API or whatever it is that you're testing against. And so you can go in and configure that I want there to be 300 workers, and I want to simulate 10,000 users. All that stuff's configurable. There is the interactive sort of like web UI here that you can go in and click those things, or you can define it within that Locus file to have it kick off automatically. And then you can capture the results. You can view the test as it's running in your web browser. It'll show you the current you know, request rate and different things like that. It'll generate some rudimentary charts for you so it can kind of graph that out. And then it can also spit the data out like CSV format. And then it's sort of up to you. And this is going to be a general theme throughout all of these tools, is that these are each different tools managed by and developed by different people. There's no universal, you know, load testing or benchmark data format. Obviously, if you've got existing observability tooling, like, you know, say a Prometheus and Grafana and stuff like that out there, you can build your own custom dashboards to collect these things and compare that over time. But they are all going to sort of be different in how they produce data within the tools themselves and how you need to compare them. So again, we could probably write tons of books and do hours upon hours of presentations on what we think you should do and stuff like that, but gives you a place to start, do what feels good for you and your environment, and go from there. So my Locus demo is not working at the moment, so I'm not going to try to do that and fail right now. So we'll just kind of move on to the next tool here. So we just covered kind of networking northbound, southbound. Let's talk about networking east and west within a cluster. And we have this great tool, K8s netperf. I think I have a tab already open here. So yeah, managing monitoring network performance inside a Kubernetes cluster. So what's cool about this is if you sit down and start thinking about, well, what's important for me to know about networking inside my Kubernetes cluster? Well, you might have some workloads that say daemon sets that mount the host networking namespace from the underlying node and do some type of cool eBPF stuff, this, that, or the other. So, okay, we want to check what host networking looks like on a pod on one node. All right, well, you might have some things that are just kind of like agents that are sitting there watching, and then they push information out. And so they only ever really talk on local host. So we want to make sure we can test networking on local host through the normal pod network. But then sometimes you got pods that need to talk to each other within a Kubernetes cluster. So we want to be able to test a pod talking to another pod. But there's probably a difference between two pods talking to each other on the same Kubernetes worker node versus two pods talking to each other that live on different Kubernetes worker nodes, right? What if you talk to the pod IP versus the service IP? You know, you have the load balancer in there or not. All sorts of different combinations. And if you sit down and try to map them out and like build a test for each one, like it's a lot of work. And luckily, someone else has already done this for us. So the K8s network netperf tool has I think it's, yeah, all 9 different scenarios that it tests here. Kind of those things that I talked about there with host networking, local host, pod running on the same node, pods running cross nodes, all those different combinations in play. And then it does that with 3 different tools. It uses iperf, netperf, and Fort.io. So some of those things are to test HTTP response. Some of them are test just raw network transport. And some of you can test like gRPC stuff. And then it does that with different, it can do that with different MTUs, different packet sizes, different things of that nature. So it's pretty thorough. And essentially you just deploy a couple of daemon sets and pods to your cluster and then execute a test. So I've already got some pods deployed out here on a cluster, and I'm going to see if this will run. So I've got these pods running out here, and somewhere in here, I'm going to execute this test. So this is just a little Perl script. Again, this is from that project. I don't make any claims to any of this stuff. And essentially what this Perl script does is it execs into the different pods, and it kicks off the tests of those iperf, netperf, and Fort.io tools to make sure that one of the pods is set up as a client, one set up as a server, and then it starts and kicks off the actual traffic generation there. So we'll do this. We don't have to watch the whole thing. But just to give you an idea of what happens when you do this, under the covers here, like everything's being written out, kind of standard error out to this log. And that includes some just sort of info bits as well. But it goes through and it scans, it checks out what all the nodes in the cluster are. It makes sure that all the pods that it expects to be there are there. And then it kind of calculates which ones it wants to be the client, which ones it wants to be the server. And then it goes through and starts running these tests. And so it'll be good. It'll tell you I'm using the iperf tool. I'm doing a throughput test between this pod, and it got 24.1 gigabits a second, you know, and hey, this is DigitalOcean Kubernetes, by the way. So shout out to them. Their stuff's not too shabby. For a public Kubernetes service, it's pretty good. And as you can see, it's gonna just go through and run all these different tests, and it's gonna do like TCP-RR, TCP-CRR. So that's like reusing an existing TCP connection versus closing and starting up a new TCP connection on every request. It's very thorough. It's really cool that somebody spent the time to put all this together. Now, the sad part here is that the output is kind of what you see here. Yes, you've got numbers in there, and yes, you know what test those numbers are associated with, but something usable that you can like programmatically compare to one run versus the next run, that might be something you have to put together yourself, or maybe you already have the great observability stack in your clusters and you're capturing all that stuff. And speaking of observability, hopefully we should be able to see some of this. I'm going to try to zoom in here to like the last 15 minutes. And yeah, so we can see we had like basically zero traffic going on in this cluster. And then we see traffic, you know, jump up here around almost 2 gigabytes per second. And we're around 250,000 packets per second here. And this is one of the smallest cluster sizes that you can build with the DigitalOcean Kubernetes service. So not bad for you know, $10 a month Kubernetes cluster. But yeah, so this is also the important, you know, like the data is the important part in all of this benchmarking and load testing here, because the idea is that you want to be able to compare what you do one time to what you do the next time, and make sure that you're maintaining or increasing your performance, or it decreases and you know why it decreased. But this can come in handy if you're, say, you've decided that you want to use the Cilium CNI for your Kubernetes cluster, and you're trying to figure out, is it worth it to you to run with the kube proxy replacement or not? You know, or compare it to your current CNI. Build a cluster with each, run this benchmark on there, and just look at the numbers. Now, with anything, you probably want to run any benchmark a few times at least, so you can average out any type of isolated events or anything like that. But when you make decisions on things like that, you know, this is a very good way to do it, because you can drive your decisions with data, rather than saying, you know, I like the paint that came on the outside of the box on this CNI versus that CNI or something like that. But it's also really cool, you know, personally, I've tested this, you know, with a couple different CNIs, and I went into it thinking, well, a CNI is a CNI. You know, what difference does it make? You're going to route packets through IP tables in a Linux host somewhere and call it a day. Well, turns out not every CNI is the same. And some of them, you know, take IP tables out of the picture altogether. And you can see some drastically different results here.
Yeah, there's some really interesting stuff happening in the CNI space regard to eBPF and WireGuard and some interesting encryption protocols.
Yeah, that's
our policy.
One that I've jumped into recently of just literally comparing like what happens inside the like worker node network stack, you know, going through kubeproxy still, but one CNI provider versus another that implements a lot of their like rules and logic in eBPF programs versus in traditional user space programs. Like it can be very drastically different. So we've talked about networking in and out of your cluster, networking between the nodes and pods and services inside your cluster. Let's talk about storage. So lots of different storage providers out there, lots of different storage abstractions for Kubernetes out there as well. We have the CSI interface, and that can plug into a lot of different things, whether it's your, you know, the things people think about the most with like your public cloud storage providers, or you put something like a software-defined storage layer in between with like a Ceph or a Portworx or a Rook. And then you can kind of abstract where the underlying storage comes from, whether you've got local storage, NVMe type stuff in your bare metal Kubernetes clusters, lots of different things there. And so maybe you want to test that storage. Maybe you have a hybrid cloud environment and you've got some Kubernetes in your own data center and some Kubernetes in a public cloud provider. And you want to make sure that the user experience for your development teams is the same from a storage perspective. You know, you deploy a database workload in your own-prem Kubernetes, you deploy one in the public cloud Kubernetes, like maybe you want to make sure that the IO performance is similar. Enter this tool called dbench. I've actually used a couple tools in this area. I used to use one called vdbench that I've used like going back way when, like my Unix, Linux days. But dbench seems to be fairly popular these days, has a lot of the same capabilities. And quite honestly, there's some pre-built images out there that make it a little bit easier on you. You can, of course, build your own images. And this is open source here. And essentially, this uses the FIO tool to generate IO. It'll start up and it will create some test files, and then it will run through different testing parameters for storage throughput, storage latency, storage transfers per second, like similar stuff to what we saw with the east-west networking stuff, but related to storage. So FIO, standard Linux IO tool. One of the things here that I kind of want to bring up is this is the entry point for the container here. And this just has a bunch of tests defined in it. And you can come in here and see that they separate it out by like read IOPS, write IOPS, read bandwidth, write bandwidth. They do latency as well, sequential versus random versus mixed, read write, you know, all sorts of tests here. Again, very comprehensive to what's out here. But the cool thing is, if you've got an existing workload that runs in your Kubernetes environment and you want to simulate that exact pattern for storage, you can set up this test to mirror that, create your own image and run that. Say you've got a big, you know, financial database or whatever, the horror of running that in Kubernetes these days, but say you have that. And you know that you know, during the end of month billing cycle, you get, you know, IO and read write patterns this way, that way, this size, that size. You can define all that in here to simulate that. So it's less of a how fast can it go and more of a like, how does this perform and is it the same as what we expect it to? So that, you know, going into the end of the month, if you need to maybe add some more nodes to your cluster, you maybe need to add some more storage or something. So this one again, we'll jump back over here, and I just want to make sure. And by the way, when I run K here, I have an alias where K equals kubectl. I'm just a little lazy when I type. So just know that K is kubectl. So I'm just going to make sure that this is cleaned up from any previous runs here. And then I'm just going to apply that back. Now this schedules a Kubernetes job that schedules the pod and kicks that storage, those storage tests off. And again, I'm not doing anything special. I haven't changed anything from what's out there in that like core raw dbench repo. I did just compile the images myself and push them to my registry. So I'm just going to try to follow along with the job logs here once the pod gets scheduled. And you can see it's got a working dir that's just /data. That's a blank directory that gets created on top of the persistent volume that gets mounted in. You can go in and show you that. You know, you can, if you've got multiple storage classes, you can target, you know, a specific storage class. Say you've got one that's, you know, all flash storage and one that's like regular spinning disk for bulk storage. Like you can test them independently. All that stuff's configurable. In this scenario, we're just doing a 10 gig volume using the default storage class in whatever DigitalOcean's environment is. And you can see that it's going to start going through. It creates some files, like 2 gig file, and then it starts running through and doing the IO tests, and it'll print out some disk stats and things of that nature. And if we jump over to our observability tooling here, I think there was a dashboard here that comes out of the box that we can look at for. I'm gonna have to change this to like the last 5 minutes and scroll down. Yeah, so you can see down here, we've got some IO going, you know, 100 and something megabytes per second. I have seen these panels here for whatever reason take a little bit of time to update. They're not quite real time based on the PromQL query that they're running. But just know that there will eventually be pretty lines here that show the storage traffic and whatnot. But kind of the same line there. You know, again, we're wanting to test it, keep track of what those results were against a defined set of parameters that we want to make sure that we can, you know, have sequential read speed with X number of IOPS, X amount of throughput. Each time we test this, maybe you upgrade your CSI driver, maybe you change CSI drivers, maybe you change your storage format, maybe you upgraded your Kubernetes cluster and you find some bug in the new Kubernetes release that affects storage in some way. But overall, that's the point of this stuff, is to be able to track those sort of things and inform those sorts of decisions. So this is one that I've had some people be like, well, Joe, that's not really performance. You know, we're talking about Sonobui here. And again, it's a conformance testing tool. And it's like, well, that's conformance testing. I'm like, well, yeah, but some of the tests in the end-to-end conformance tests with Sonobui actually time the amount of time it takes to create a pod, delete a pod, create an ingress, delete an ingress, all those sorts of things. And I think those are those are probably more important, like core Kubernetes functionality is probably more important than a lot of these other things, because the activity of creating and deleting pods and other Kubernetes resources, I can almost guarantee you happens more frequently than like large spikes in network and storage traffic and things like that. If you can't create a pod, then it doesn't really matter if you can get traffic to it. Or if you can't create a PVC and a PV, then it doesn't really matter if it has a high throughput or can handle a high number of IOPS and stuff. So I think the Sonobui type end-to-end conformance test is just as important for functionally testing the performance of your cluster. Again, how fast can I create a pod, delete a pod, different things like that. And I've seen over time where different Kubernetes versions can drastically impact that, or where there's some threshold associated with like a Kubernetes API server setting or a kube proxy setting to where everything works fine up to 200 pods. And then on that 201st pod, everything falls apart and performance goes down. And it's very, very hard to explain that, you know, because you might not be aware of that threshold. There might be some default that's just always been good until it wasn't good anymore. And this sort of thing can help test that. The Kubernetes project does a really cool job with these end-to-end tests where basically every PR that comes into the project kicks off a series of end-to-end tests, both for like, does it work? Does it still perform, create pods and do all that stuff? But also, how does it look when I create 100 pods or 100 nodes or 1,000 pods or 1,000 nodes? Like those are all very important things that are kind of the different knobs and things that you can tune, different thresholds that you can cross. And knowing about them before you get to them is very helpful. And so that sort of wraps it up. You know, obviously there's lots of other things that you can put eyes on to watch the performance and manage the performance of, and there's a whole series of things that we could get into on how you can get better performance, and maybe we'll dive into that down the road on another talk. But that's enough for me talking here. Hopefully you learned something, but if there's any questions, I haven't been watching the Q&A. Feel free to ask questions. Otherwise, we can move on.
I don't see any pending questions. I guess we'll give it a sec, see if anybody posts anything. I don't see anything coming in right now, but as a great overview of the tool set.
Question. Did you think about doing any kind of like chaos engineering type stuff when you were running these tests?
Yeah. So at different times, these individual tests have become chaos engineering tests in and of themselves. Like with our ingress testing, we were able to see that, you know what, we can topple over a load balancer sometimes just with concurrent connections of the virtual users before we actually topple down an ingress controller. So in that case, you know, like, yes, those things, like like we've legitimately broken things in testing. Like, what are the upper bounds on this? You know, when do the load balancers start to smoke? But no, as far as any of the more formal, like the gremlins or the you know, chaos mesh, or like there's a ton of the different tools out there. I haven't specifically jumped in and done that from something to track as part of this type of thing, but absolutely, it's a benchmark, you know. Anything that you can test in a specific way with a defined set of parameters and then compare that between different iterations, you know, like that's a benchmark. So could absolutely have, you know, chaos engineering. And I mean, that's an interesting thing. I don't specifically know how you would like score other than pass or fail, you know, of a particular system deployed on Kubernetes with, you know, chaos engineering stuff going on. But sure, yeah, absolutely could be a part of this.
Yeah, I just know that like when we have done things like this in the past, intentionally or unintentionally, a lot of the things that ultimately caused sort of the cascade to start were things like, you know, a load balancer falling behind and maybe getting taken out of the pool, which seems like a normal activity, but then you realize that load balancer maybe had some like sticky sessions or something like that, and then all the sessions hit the database to reload something because maybe you're dealing with something like Ruby or another joyfully database enjoying language, and then like, you know, just so I think that is kind of some of the things that I've noticed, I guess on our side is, you know, just like trying to plan for some things that seem normal, but are changes to the system, you know, without, and then causing these additional failures under load.
Yeah, I think that like there's an important thing to just kind of reiterate, like a lot of the things that I talked through and showed there are like as simple as you can get it, basically. There's a lot of stuff, you know, for any large, you know, distributed system, you want to make sure you're testing it end to end. And so, you know, those tests can look very different from what I just demoed. You know, a true distributed system, like building the tools to test it, can be just as complex as building the system itself. But that, you know, it is very worthwhile to spend the time doing that. Like, you know, as you're building out parts of the distributed system, you know, not just the unit tests, but functional tests, you know, like those things are important to be able to test the components individually, but hopefully you also have end-to-end tests that can test the system as a whole, you know, end to end and all the components, whether that's a traditional 3-tier application stack with, you know, web end, middleware, database type stuff, or something that looks completely different than that. But it definitely is much more of a pain in the butt to try to build that tool after the fact.
Yeah, I was kind of fishing for Gremlin too, because, you know, I feel like there was a point where there was definitely a lot of, you know, mind share focused on the chaos engineering strategy. And I don't know if that has, I can't tell from where I'm sitting today if that's fallen by the wayside because it didn't really kind of get ingrained as it might have, or if it's just been kind of operationalized as a normal procedure.
You're muted, Joe.
Thank you, Alex. Yeah, it looks like Shaha, and I apologize if I'm pronouncing that wrong, had a question here. Do you store any automated benchmark results over time so you can see how you're trending? Yes, we do at T-Mobile. And this is something where we have taken the like kind of ad hoc, you know, approach in the past, where a lot of the times we test specific, you know, like retail events or specific network events and things of that nature. So it's not as frequently. Some things we test like on a daily, weekly basis. And how we capture that data is a little bit different depending on each test. Again, some tests are pass-fail. Some tests we actually want to, you know, compare against a defined set of parameters. And that's something that we're looking at maturing right now. So you can think about that as ranging from anything as simple as I've got a markdown file with the test results in a Git repo to we automatically kick off a pipeline that schedules a test, grabs the output from the tool and publishes that to like a static website or into our, you know, observability platform. But that's an area that we're looking to enhance the tooling that we do have to make that better.
Something that I've used Locust for in the past, some of my infrastructure team members back when I was working with Beatport automated a Locust test that you could start from GitHub, and it would go and run in our stage cluster, and then publish the results to a repository where you could compare the performance of the application logic, the API that we were developing. So that's like a good example. Like, I don't know if you would necessarily want, right, like the iPerf statistics, like between like cloud machines. Maybe if you're worried about like your network cards, like deteriorating something, like you might want to run that, you know, once a month or something. But otherwise, unless you were like making a change or upgrading like the types of servers that you're working on, I'm not sure that I would be interested in running like just raw performance benchmarks regularly until, you know, like actuating a piece of the infrastructure that might make a difference. But for API testing of the actual application logic or systems that you're running, makes sense to me.
Cool. Doesn't look like we've got any other questions pending. All right. Thanks for that talk, Joe. Like I said, a great overview of the tools kind of available to us and how to go about getting into benchmark. Up next, you've heard him talk a little bit just now. Excited to hear us talk, though. We've got Leigh Capili, a staff developer advocate at VMware. He's going to be talking to us about securing GitOps Debug access with pinniped, Dex, and GitHub.
Thanks, Alex. Yeah, I'm really excited about this. I finally got a solid copy of this demo working, and it's all GitOpsified. So, you know, this, and these repos are also pushed publicly. I'm just encrypting the secrets using a tool called SOPs. So I'll show you a little bit about that pipeline. Let's go ahead and hop into my demo environment here, right? So I'll make sure to try and keep font sizes large and stuff, but yeah, you know, I love interactivity. Thanks so much for sticking here. Of course, some great content from Joe, and I want to take an opportunity to one up as well. So here we go. So what am I talking about today? I am talking a little bit about login. And login in the sense that when you are collaborating on a Kubernetes system, you kind of have this fundamental problem, right? So why do we use Kubernetes in the first place? How do we get here? Well, when we don't need the screen for this yet, right? We are here because we tend to work in environments and on teams and in organizations where we have distributed applications, right? We have lots of servers. We run around all these apps and like stay on top of our config. And when I want to make some changes to the way that the app, you know, operates, whether it's application logic, whether I want to implement some MTLS between a couple components, if I want to break out some of the pieces of the libraries into another server and do some microservices, maybe pull apart my data stores. You know, it's like we have these collaboration problems. And then you got ops people, right? And the ops people, they're in the system. They're like, man, I got to make sure that I keep my Linux kernels up to date. And well, we should probably have some people monitoring dependencies of our application repos. And I got to make sure, man, like when those container images are being built in the pipeline, that we have some story about making sure that those container images stay up to date. So I should probably do some CVE scanning. You know, you got business people who are like, hey man, when is that feature that we're talking about going to be released? I mean, I know like you're working towards reducing the error budgets and whatever, but I want to know what version of the app is deployed. So you can hear, right, outside of the technical tools, outside of using Kubernetes as a distributed operating system for lots of computers and lots of applications, right? The fundamental problem that we're solving with these tools is how to work with each other, right? Different people have different needs. There are a lot of different API groups in the Kubernetes API. And some of those API groups, they're interesting to security people. Some of those API groups are interesting to application developers, right? And other API groups, you know, maybe a large set of them are going to be like super interesting to a platform engineer type person who's trying to implicate and stay organized with versions of everything that are deployed on the system, right? So we have this problem, right? Now we got a distributed computer and you want to go use it, you got to log into it. Right? Because not everyone's the same person. Not everyone's going to be loading up, walking up with their admin kube config like, hey, please give me keys to the kingdom, right? What, you're going to use the impersonation API to drop your roles so that you can get read-only access to, you know, all of the application namespaces and just ignore kube system, right? That's not realistic. And so we need something on top of Kubernetes, right? Something that extends Kubernetes authentication mechanisms. And there are a couple ways to do this, but most of the ways to do this involve modifying the API server flags and adding some certificates in there. Cool. So what I'm going to talk about today is a way to implement login and identity on Kubernetes, but without having to own the control plane configuration. This means that what I'm demoing today can be done regardless of whether or not you're hosting your own Kubernetes cluster or using a Kubernetes service provider such as GKE or K8s, right? Or if you're using DigitalOcean services, like you can go, somebody can give you a cluster. It doesn't matter how the API server is configured. It doesn't matter. As long as you've got some like decent admin access, you can install pinniped. So now let's take a look at the pinniped website, right? What is this? This is batteries included Kubernetes authentication, which is sort of a lie, but I'm working on helping make this not a lie as much as possible. But basically, pinniped, it does a couple of cool things, and there's two components that we're going to be looking at today that are the supervisor and the concierge. And so the supervisor, you're going to have like one of these for every login domain that you want, right? So say I got 10 Kubernetes clusters, I want a single login domain across all of them. One of those clusters, I'm going to pick as like the management cluster, and I'm going to put the supervisor over in the management cluster. And then the concierge is the thing that shuffles around and talks to the supervisor to get credentials for my particular cluster that I want to log into, right? So I can have a single federation domain across 10 clusters, a single supervisor deployment, and then I just deploy the concierge across all of my fleet, and I can log in everywhere with some account. Now, pinniped supports hooking up to any OIDC provider, and it supports a bunch of other stuff. You can hook it up to LDAP, you can do all these things. But today, I'm not interested in being a nerdy authentication person. Like, I'm not gonna go and try to figure out like if I can like set this up with my like Google Auth or integrate it with Active Directory, because I'm a hip nerd, right? I'm not trying to log in with my Microsoft AD stuff, right? I'm not trying to just fall back to some Google accounts that aren't related to any of the infrastructure that I actually manage. What I want to do is log in with my GitHub account because I'm a hipster, right? And so what we'll use is an open project called Dex. And Dex is going to allow us to turn GitHub's non-OIDC compliant OAuth 2 system into an internal OIDC provider inside of our supervisor cluster. Right. So, of course, you know, I'm starting to get into some really weird, complex ideas. And I know I've already shared a couple of acronyms that like some people, they might not know. If you're feeling like you want to dig into a particular topic, just pop it over in the Q&A channel. I'm definitely watching that. But let me show you the value, right? So I have my identity in GitHub here. And I also have an organization. Just like most companies, they have a GitHub account and they have an org. My org is called StealthyTail because this is where I tend to like manage Tailscale auth stuff, right? I like Tailscale. So this is what I call my org. You can see I even pushed the control repo that has all of the Flux manifests and stuff here today. So if you want to go and check out, just go to StealthyTail, TCE Flux pinniped. That's the control repo for today. Now, if I go to settings, then when I scroll down here to developer settings, right, and then I click on this OAuth apps bit right here, you can see that I made this OAuth app called Flux TCE pinniped demo, right? So what I did is I came in here, I made a new OAuth app, I named it, you know, and then I filled in these details. I'm going to be using a domain that I just bought in AWS. I just clicked the button and bought YAML.tv. I'm pretty stoked about that. And then you basically I'm going to host Dex. So remember, Dex is going to talk to GitHub for us and turn it into a secret little OIDC provider in our cluster. And then basically just got to configure the callback URL, right? So these things are kind of tightly coupled to my control repos configuration, right? And then I have like a secure ingress setup that I can show you that shows how that happens, right? And then the only last bit here is you got to click this button and generate a new client secret, and then it'll show you it just one time. So what you do is you copy that secret, and then you pop in to your control repo. Make this just a touch bigger here. VS Code's being like super slow though. There we go. And then you'll go to your configuration. So here's this config folder. You can see that this is a super complicated repository with like a lot of different bits of config going on. But I promise that the pinniped bit is simple. This just has my entire secure ingress stack here and like is using 3 different package managers. in the management cluster config for this auth config and auth infra directory that gets used by the GitOps system, there is this pinniped values file. And this is all just whatever we want. We define all these values. They don't come from anywhere, but we want to configure DEX, right? So DEX has this client ID and client secret. Now you can see that this is encrypted, right? But I can just like go in here and SOPs edit, and then I'll just paste that value there, and then it just saves encrypted. So that's all that's needed to configure the repo from a GitHub perspective. You go generate your client secret after you make your OAuth app, you paste that secret in this one line right here. Probably you would want to generate, a bunch of unique values for gluing DEX and pinniped together, and then put in your domain name in these files. So these two files are the configs, and then you're good. If you have an AWS cluster, you can go and apply this repo and probably get you pretty close to exactly where I am today. And this just applies with a single Flux bootstrap. If you never used Flux, it's a declarative GitOps system, lots of tools like it. This repo is also using cap controller as well internally, and a little bit of Helm controller, which is part of Flux. So all you do is you just like Flux bootstrap to your repo. But where we are is just make sure that we're in the right cluster as well here. Okay. So this is my 4-node AWS cluster. Yeah. And this was stood up with Tanzu Community Edition. And so it's not like an EKS cluster or anything. It's a cluster API managed. And here are the customizations for the different pieces of software that I'm ensuring are installed with Flux, right? So my secure ingress setup, the package repos for the Tanzu system to install like Contour and all those things, it's part of this ingress setup. Here's Kayam from a Helm repository. I have a webhook configured so that my Flux system, can respond quickly. And then here is the 2 bits that actually set up pinniped, the supervisor, the concierge, and DEX, and then configure them for my needs, right? Based off of those values. So you just Flux bootstrap, and there's dependencies between these things, and it just rolls out, and you don't touch anything until it's working, hopefully. And when you do that, so I'm talking to the cluster right now, right? And if I were to say, ask pinniped, who am I? Which is very similar to just like using kubectl auth can I, then you'll see right here that it's spitting out that I'm the Kubernetes administrator, right? Which is exactly the sort of identity that you don't want to give to everybody, right? I am using a administrative config. This is kind of a break glass style thing. You should lock it away inside of a password manager, and like people shouldn't be just accessing a cluster like this all the time. But since I just set this up, this is what I have right now. But if I do a pinniped get kubectl and I write that out to a kubectl file locally, then this is something that I can give out. In fact, I feel, so you can see right here, it went and it looked at a bunch of things inside the cluster. What the heck is a JWT authenticator? What is this like issuer URL? Like I deployed all of this infrastructure. How is this supposed to work? Well, if you actually get all of those objects, so here's a authenticator, a federation domain, and an OIDC provider. This is the management cluster, and we have these 3 resources here that are responsible for configuring the pinniped side of things. And then DEX is just like a secret that I converted from a config map using some fancy YTT templates. But basically here it's telling us, like this OIDC identity provider is ready to go, right? It's hooked up to the domain. It's good. It's happy that it's talking to DEX. So that's awesome. And so I generated this kubectl, and the kubectl that it gives me is actually safe, totally, completely safe to like post in public if you want, because there's nothing actually secret in here, right? There's a CA, just to validate that what you're talking to is what you want. And then there's this user exec line, right, that executes a credential provider, and it is executing pinniped to log in, and that's it. Like there's nothing actually secret in here except for telling somebody how to go to the cluster and log in. So what's cool about that? Well, when I use this kubeconfig, it's going to talk to the concierge, and what the concierge is going to do is it's actually going to give me credentials that are good only for the Kubernetes cluster I'm talking to. Now, there's a very subtle thing that's happening here that I want to point out that's important and that's very unique about the security model that pinniped implements and does for you if you just follow the normal deployment topology. You can actually do this like without using the concierge. And what the concierge is good for here is if I log in to my stage cluster, the credentials that are actually transmitting the wire that allow me to talk to stage are not good credentials to talk to production, even if my identity has login access to production. So there's actually an authentication boundary in between each cluster, and that's very important. So, okay, lots of talking, right? But I got this kubeconfig, and what does that do for me? Well, if I run whoami without the kubeconfig, I'm still Kubernetes admin. But if I set that kubeconfig and I run whoami, then you can see that the Kubernetes API is telling me that here's the cluster and that you're actually logged in with the email that's associated with your GitHub account. And that you also have the role of your or a group that has your organization's name, as well as any GitHub teams that are part of your organization. Here, I also authorized that I would be part of another organization. And then you can see that I have the system authenticated group with Kubernetes. And so I have this username and I have this groups thing. And like, why is that valuable? Well, now the username and the group fields, those are actually things inside of Kubernetes that you can role bind to, right? So you can make role bindings, you can make cluster role bindings to other roles or cluster roles. And so it's super sick, right? Because now that the cluster knows exactly who I am, then, well, I guess I kind of didn't make it very clear how this happened, huh? Because you didn't even get to see me log in, because I already logged in before did the demo. Trying to figure out how to invalidate my login token now, which is, I think I can just do pinniped log out, something like that. I forgot where it is. Because these, there's also a pinniped config directory, I think, if I remember correctly. Sorry, it's just been a little bit. Yeah, I can just delete this. Cool. Let's do this one more time. Hopefully I didn't mess up anything since the last time I logged in. So if I just do this one more time, then I have no credentials. And it says, yo, you should probably open up your web browser. And if it has the ability to do browser open, then it opens up the web page. And so what happened is pinniped, the concierge, talked to the supervisor. The supervisor was like, hey, you got to talk to Dex. So then I got redirected to Dex, and then Dex was like, yo, you got to talk to GitHub. And since I'm already logged into GitHub in my browser, it's like, okay, well, I know exactly who you are. And the first time I did that, I had to authorize the OAuth app. But now that it's authorized, it just takes the login and succeeds. So there's the login succeeded. I can go back and then I get my groups and stuff. Right. So that's the experience. And it's got refresh tokens because, like, that's how OIDC works. You log in once and you should be good now to talk to the concierge using these different kube configs, access all of your clusters across your fleet with unique credentials. So there's the value add. just to start off on a strong foot. So unfortunately, I did this demo last week and it didn't work out well. So
Hey, Leigh.
Yeah.
You mentioned that it does support like the concept of refresh token and stuff, but there didn't seem to be any of the normal fields where I would expect to see like refresh token and whatnot inside a kube config. Is that managed like the supervisor or?
It's managed in that config pinniped directory.
Okay.
So what I probably could have mentioned a little bit more clearly was one thing that you do have to do aside from have that kube config is you need to have that pinniped CLI tool, right? And everyone needs to have that if they're, the developer or the SRE or the business person that you wanted logging into the cluster to be able to see whatever information, that you're going to role bind as available to them. Then they need to have the pinniped CLI locally so that the pinniped CLI, when the kube config is executed, in order to get the credential helpers stuffs, basically this login OIDC is going to provide all of the details to it. And then if there are any tokens that need to be provided to kubectl, that will just be done via standard out. And then kubectl will just have that in memory for the execution. And then if you need to get your refresh token, then that's going to be, I guess there's probably, there's not much harm, and because I'm going to decommission all these secrets after this talk anyway. So I should be able to pretty safely show some of these things, right? So there's like a sessions directory here. If you look inside the sessions directory, then all of this state management of the actual secret values, like that token right there and the refresh token, are stored outside of the kube config. So that's why the kube config is something that's safe to just like send to somebody, right? And if it actually accidentally gets published somewhere, like you don't have a credentials leak or that sort of thing. And does that make sense, Joe?
Yeah, and one follow-up question on that. So are there libraries for pinniped that can be imported? Like if say you have an existing type of CLI to authenticate to your clusters via some OIDC path flow or whatever. Is there a way to integrate like pinniped libraries in there so you don't have to use the pinniped CLI, but you still get all the required stuff happening under the covers, or is it pinniped CLI or bust?
I think the pinniped CLI is implemented in Go, so I don't see why you couldn't go and just import it into another CLI project. But at the end of the day, the kube configs that pinniped generates for you are, if you want to be able to use those, like by like using a cluster access CLI that your platform team built or something, and then it spits out kube configs that people can use, then that kube config is going to want to exec the pinniped CLI. So you may have to modify some things. I would probably just have the pinniped CLI as like a dependency, right? As like a concurrent tool, just like how people need kubectl or they need some log tool or that sort of thing. A lot of CLIs that people build also exec out to things like JQ. So I would just put it in that bundle of stuff that you expect to be on the developer laptop or the tools container or that sort of thing. Yeah, I mean, there's no reason that you couldn't like vendor it into your project and then change the way that the kube configs are generated. Just like replace the command that you're executing with whatever command tree you're using. And that's a cool question. I hadn't thought about that at all, but it would be a neat extension point. And, anyway, so I guess with the kind of the value being shown there, right? This idea is like, what's the point, right? Like Well, you know, there's one more piece here that I can show, which is once you've set up, so like here's the configuration for none. It's like there's a secret here that holds like the DEX credentials, right? There's an OIDC identity provider that gets set up. Like here's all the details about how pinniped should talk to DEX and what sorts of claims it should be making, right? So this is where the username gets set to the email field of my GitHub account, but you can actually change this. Like if you want people to be using emails, that's the recommendation from the DEX project. But because it's a more stable user identifier, people can change their usernames. But if, you know, people aren't changing their usernames often, it's they'll probably just lose access, right? And then you'll have to update the role binding or something. Probably I would never bind, like role bind to a user with a username anyway. I would probably bind to their GitHub teams with groups, but that groups claim is what allows that to happen. And there's a couple of other settings that you can look at to sort of configure there, but that's like all of the supervisor, DEX, and management cluster configuration, right? And that's the part of the story that lets you get your platform started. All right, and then the way that you scale it out horizontally across more clusters, like unless you need to create more authentication domains for whatever reason, you're probably good at just a single management cluster, a single instance of DEX and the supervisor configured to talk to GitHub. Now, now you want to look at configuring the workload concierges, right? So if you've got lots of workload clusters, then you're going to want to generate a unique cluster identifier for each one of those clusters. A good way to do this is to just get the UID of the Kubernetes service inside the default namespace. That's as good of a cluster identifier as any number of things, since Kubernetes doesn't really have one of those things yet. Then it just produces this these two directories. So this is literally just a dump of the YAML of how to install the concierge with no customizations. Well, sorry, I just clicked out of my thing. A dump of the YAML with no customizations whatsoever. It's just literally install the YAML from the upstream project. And then here's the config. It's a single JWT authenticator custom resource. You go and you pop this thing into your workload cluster, and your workload cluster can log in with pinniped. So once you go through the setup of, like, you know, making sure that you have TLS and that you're you're routable, you know, to whatever network location you're using. Like if you want to be on the VPN in the private network, you're deploying pinniped there. Get the supervisor and DEX all stood up, and the OIDC flow is working in your management cluster. Then you just got to make sure that like when you talk to your other clusters, you can still talk to pinniped, and that's the experience. It's the same thing. You just you change your kube config, modify your kube context, and you generate a kube config for that new cluster that uses the pinniped exec method to get the user credentials. And then when you change to that context whenever you want, it will try to log in with GitHub. And so basically you just have to copy this into the rest of your clusters and change the ID. And so it's pretty easy to scale out after that. And so now that you have the platform, then the point is, like, we want to basically be able to scalably collaborate with each other, right? So zooming back out to the problem that we're solving is that we have a desire to navigate to the control repo where I would collaborate with my teammates, right? So it's like, maybe we have some Terraform or some company HR person, you know, goes into the organization's teams, right? And maybe you're adding like some people in here, right? So you invite a bunch of people, they accept their invites, they join your new thing, you're ready to collaborate with each other. You add some teams, you split up the teams up. Here's the administrators, here's the developers, here's the developers for super secret project A, you know, and then here's like all of the business people. You make teams and you put people into those teams. And the cool thing is, like, this is something that most organizations are doing already all the time, right? Like if you go to your GitHub org and you look in here at these pages, there's probably tons of teams with tons of people in them, right? And so you just deploy pinniped supervisor and Dex to your clusters, configure it to hook up to an OAuth app, and you're ready to start figuring out who's logging into Kubernetes. And that allows you then to go to your control repo, where you can start adding to the, so like if I go to this config folder here, there's this folder called secure ingress package install RBAC, right? Like I've already got RBAC definitions in here that are binding to service accounts for my applications and my package installers inside the cluster to go and do the things that they need. This one's just binding cluster admin for to install an add-on. But like, I can also manage the role bindings in the exact same way for the access that people should have, right? And I can start committing those role bindings. I think I took some notes on this. It is in down here at the bottom. Yeah. So, you know, like here's the imperative commands to run kubectl create. And here we are role binding. We're creating a cluster role binding to the admin, the pre-installed admin cluster role. So I don't have to define things, but there's great, you know, predefined cluster roles in there, and you can add more for yourself. Like if you are just, say, role binding the cluster role for admin to a particular namespace, right? Like that's a pretty granular permission there already. And you don't even need to create any resources in order to do that aside from the role binding. So, you know, there's no service accounts or stuff. Like you're just making a single object and you can give people the access they need. And it's just a good experience, you know? So this is a great way to give yourself the basis for an identity platform for all of your engineers to be able to collaborate with each other, right? And, you know, there's lots of very interesting things happening in this control repo that I'm happy to delve into. Lots of hard problems being solved through the dependency management with the GitOps system and the use of Flux resources. And like I'm using cap controllers, Carvel packages that are like more organized than Helm charts, in my opinion. I'm using a Helm release, you know, that came from somewhere on the interwebs to set up KIAM. There's like IAM roles being overlaid onto pods that come from packages that I didn't write, you know, and that's all in there, and it's all declarative. So happy to delve into any of the interesting organizational problems or like code organization problems that you might have when trying to set up a complex install. This does it in mostly one step. There's a little bit of Terraform, you know, beforehand. And yeah, I'm not even looking at the control repo anymore, but, you know, I'm totally happy to take questions, delve into things, and also just happy that this demo works. So
yeah, that was awesome. Is there, so like, I've seen things laid out in a bunch of different ways between like the concept of a control repo and whatnot. At the end of the day, with something like Flux in the picture, that's basically delegating the installation of something in that control repo into the cluster with whatever credentials are configured within Flux and blah, 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 blah. Is there a way with any of this to sort of like tie into the concept of like the GitHub code owners or anything like that for delegation of specific files or directories within the control repo versus anybody that has access to this repo to merge code, you know, gets whatever access the Flux tooling has?
Yeah, so that's a really good point, Joe, and a great piece of the puzzle about how we collaborate with each other. I think what I didn't touch on is that why do we all have so much of our identity and our role-based information and our teams like inside of our GitHub organizations. And it's because the Git platforms that we use are the way that we enforce policy about how we work with each other. Whether you are using separate repositories or using owners files inside of individual folders, this applies even more heavily to GitLab, where they have very specific policy type things that can control who and what team can allow approving a pull request that changes particular folders. So like that's one really great way to gate who can make changes to the cluster. Now, the other piece of this is that you're talking about is that the top level package manager or orchestrator in this system is Flux. And I've been a little bit lazy in my control repo on this, but I'll show you two things, which is that if I pop open that control, oh, not my calendar. Here we go. No one wants to see that. If I look at the cluster configuration directory, and you pop into here, so say this is the customization that applies this folder, whatever's in here, to the cluster, right? And here's where the SOPs decryption, is configured, and here's the dependency, and this is where the repository ref is put. And you can also provide that service account name, right? And if I hover over this, this is from the Kubernetes Open API definitions. This is the name of the Kubernetes service account to impersonate while reconciling this customization, which means that while I am applying this folder, you can hook up a different identity to go and do that thing, right? So anyone who's merging to this folder can become a particular identity effectively, right? They're acting as that identity. And so you can drop privileges here, right? So right now, this is using cluster admin because I'm in the Flux system namespace. But since this is just doing some authentication config, I definitely could drop this to a service account that only has role bindings in the Dex and pinniped supervisor and pinniped concierge namespaces, right? And then if you were to, put some stuff in here like network policies or other cluster roles or things that are at the cluster scope, then they would fail to apply, right? So even if they passed the review process and they got merged through, the policy of the repo is being enforced at the runtime level as well, right? So that people who are merging here are only using this folder to change the cluster in certain ways, right? But then you go to a different folder and that could have a different service account that has access to different things. Now, the service account is going to be role bound to some particular roles, right? Like there can be many role bindings and many cluster role bindings to many different cluster roles is most likely what it is you're either role binding or cluster role binding to some cluster role to either give that role at the whole level, at the whole cluster wide level, all namespaces, the cluster namespace as well, or to particular individual namespaces. And the only reason I'm being so verbose about this is that role-based access control is so commonly misunderstood, right? But that's how it works. And so those same exact roles, when you provide that service account role binding, you should probably also include the team name of the people who should have access to go and look at or view or even potentially mutate inside the cluster for debugging or emergency response purposes, like say that kube admin group that was part of my teams. I would probably also want to role bind the stuff that manages my apps to those groups. And that gets you the very one-to-one relationship of if this person has permission to commit to this directory and this directory is applied with a particular service account that has roles, then those roles can also then be granted to the user, either the read-only half or the read-write portion, depending on what you want, for when they log into the cluster themselves. Does that make sense? And then that kind of gives, like, because ultimately at the end of the day, like even if you've got webhooks and stuff is super nicely tuned and everything's operating perfectly, going through the control loop of like committing to the GitOps repository, nothing is going to give you the Kubernetes API output like back in the GitHub status, right? Like at the end of the day, like you need some debug access, right? And so if you split up your roles, right, where these are like the reader roles, and then these are the read-write roles, and then for the package installer service accounts, you bind both of those things, and then with the role bindings that you're giving to the people who actually access the cluster with their keyboard, you give them the read-only roles, right? Or the viewer roles, or maybe some constrained ones, or even maybe in a break glass condition, you give them read-write roles. Then you are allowing a parity to occur between the way that you manage the cluster declaratively and collaboratively through Git, and the way that you view the cluster and interpret status messages and events and problems and timestamps when you need to log in and see what's there. And that really encourages, it helps you keep the entire organization organized, right? Because you're not over-granting access to anyone who shouldn't have it, but anyone who would normally have a collaborative role in, like, say, updating an app definition or that sort of thing will probably have read access in the namespace that they need to, so that they can go and investigate their own damn problems instead of pinging every operator person about it, right? And so you're empowering people to get the information that they want. And I think that this sort of tenancy and access is, if you even have any management strategy around it, it's done in a half good way, right? That's normally what I see with my own personal customers, with customers that I've been part of from other businesses, and then when I used to be a practitioner at several companies before, right? It's like, regardless of whether it was Kubernetes or not, access was just a very rough and unorganized thing, and it only approximates what we actually do in our everyday lives, right? And so if we can find the good examples of how we dole up access and identity, and we can tie these Kubernetes primitives very closely to those things, and tie in the GitOps control loop so that it's very closely related to how those role bindings are put together, and you can even see the declarations inside of the control repo, you know that people have pretty granularly the level of access that they're supposed to. So, yeah. Sweet. Well, that's the big idea. Honestly, I mean, like, the only other thing I have to say is that there's a Carvel project in here. And in the config directory, there is this ingress infra directory, and like this package install here, it's a similar experience. This is a GitOps controller that is this package install resource is basically actuated in the cluster by something called cap controller, and it's kind of similar to Flux. You can see here, like, loading in values from a secret, and that there's nothing actually secret in here, so it's not encrypted. And yeah, there's that service account name, right? So like there's a particular deployer service account with role bindings that gives this permission to go and install. In this case, it's like all of Contour and the CRDs in the cluster. Right. So if somebody was like going and adding this to the control repo, then maybe they might also, need some viewer access that gives them the ability to see this kind of stuff, so that they have the ability to do their job. Yeah, and then the wrangling of this YTT project. If you ever needed to pull dependencies, like some random YAML from some HTTP server on the internet, or from some other Git repo, like here. Basically, these library directories, like this dex thing, it's got the license pulled in, and then here's the single file from the dex source control repo. I'm using a tool called Vendor to do that. That's part of the Carvel tool suite. Go check it out. This has honestly made my life so much easier. The amount of times I had this problem, It's like you just put a vendor YAML in here. It even makes a lock file for you, so your commit doesn't change on you if you don't want. And like now I can pull these things in, and then I can write YTT programs to overlay them, right? So I can show you like a simple YTT program would be like producing an ingress resource to add to the project. Right here, and like you can see that this is structured. It's not like Go templating, like there's no string indentation logic in here. It's just loading in data values and putting them in the proper places in a Kubernetes like YAML file. But there's like syntax highlighting and stuff because I have the editor integration for YTT, you know? What does an overlay look like? Here's patching the DEX deployment, right? So like we want to remove the TLS volume mount and volume. That's how you do it, you know? Pretty sick, YTT. This has made my life a lot easier. Here's replacing the config volume mount. This is probably, this is the last thing I'll leave you with, which is something that you could never do with customize. Customize is like so frustrating to me, and for like a lot of reasons. Like it's a very powerful tool, and I've written a lot of customize in my life. And it just seems like it's always trying to prevent me from doing the thing that I want to do to the YAML file. And why the heck did we even merge it into kubectl? Like we almost didn't, and then we did it again. And I just don't even know why we did that. But yeah, like here I'm replacing this thing that I'm matching by name. So you're always like matching explicitly by something instead of relying on a strategic merge strategy, or sorry, a merge strategy from like the Kubernetes API suggestions. So like nothing magic is ever happening, right? Like if I want to merge on container name, I can, but I can also like do this on like every single one of these resources. And then here, this is actually a config map volume mount, but I'm replacing it with a secret name. And then in this gnarly YTT patch, I am defining a YAML struct. And we decide how it overlays and replaces things. And then this bit right here, it basically matches this object for the overlay. So I'm finding a config map. And then I'm renaming the config map to a secret. I'm converting it from a config map to a secret. And we take the thing in the config YAML that was there. So if you, here, let me pin this. This is just something that you would never be able to do. You can do this in Helm, but then you're in Helm. So if I find the config that we're overlaying, right, this is what it looks like, right? We're going to change this, which holds secret values, into a secret. And we want to overlay all of this inline string YAML, right? And so basically, if you look at the patch, on the config YAML key, we do a YAML decode of this like lambda thing. And so lambda, A and B, so the left side is A. We load in the left side, YAML decode it, apply our updates that we defined up at the top, and then we overlay them together in this order. And then we YAML encode it again, and then we base64 encode it, and we store it to the secret. So the thing that you get in the output is like pretty sweet. It's like management auth infra samples dex YAML. And then I think it spits it out. Just gotta find it. Here we go. So it's no longer a config map, it's a secret, and it's encrypted. And then inside of this encrypted file or encrypted key value, it's base64 encoded. So that's my last little piece of candy for the demo. Lots of interesting stuff inside the control repo. And yeah. So no Q&A stuff. I see we had some cool comments talking about customize and whatever. And that's my talk. So
awesome. Well, thank you, Leigh. Really enjoyed lots of stuff to take away from that, and I will definitely be poking around that repo a little bit later. So we'll go ahead and close up the normal business side of the meetup. Thanks again to Sales Law for sponsoring the meetup with our Zoom and such. Thank you, Leigh, for coming, taking your time to present to our community here. And thanks everybody for coming and joining us in today's this month's meetup. We'll go ahead and go through our normal kind of call for speakers. If there's a topic that is near and dear to your heart and you would like to come and talk and share about it with us, please reach out. Slack, Kubernetes Slack, Tech 404 Slack, K8s ATL on GitHub, YouTube, the meetup group, or carrier pigeon, you know, however you want to reach out to myself or Alex, and we'll get you set up to come present. Or if there's just a topic that you've been itching to hear something about, or it's been frustrating you and you can't figure it out, let us know that too, and we'll go out and we'll try to find somebody that knows it better than we do and come and answer all your questions for it. So thank you there. And we'll be wrapping up the meetup now. Please hang around if you want to for some social time. Thanks to everybody.